I'm Alex Cambio,
And I'm Mike Capprini.
and this is Boyle's Law.
We know that there is empty space between particles and gas by the kinetic theory. One may ask, how are the pressure and volume of a gas related? Well, if the temperature is constant, as the pressure of a gas increases, the volume decreases, and when the pressure decreases, the volume increases. Robert Boyle was the first person to study the pressure-volume relationship in this way. In 1662, Boyle proposed a law to describe this relationship, and it was called Boyle's Law.
Boyle's Law states that for a given mass at constant temperature, the volume of a gas varies inversely with pressure. In an inverse relationship, the product of the two variable quantities is constant. So the product of pressure and volume at any two sets of conditions is always constant at a given temperature. The formula for Boyle's Law is as follows. P1 times V1 equals P2 times V2. The graph of an inverse relationship is always a curve. A balloon contains 30 liters of helium gas at 103 kilopascals. What is the volume of the helium when the balloon rises to an altitude where the pressure is only 25 kilopascals? Assume temperature remains constant.
We know that P1 equals 103 kPa. We know that P2 equals 225 kPa. And we know that V1 equals 30 liters. But V2 is our unknown. So the formula is P1 times V1 equals P2 times V2. And here's the formula. And this is the answer.
This is our demo. Currently, there is equal pressure on the inside and the outside. However, when I pump, pressure goes out, which makes the volume increase, because as we said before, as pressure decreases, volume increases. After I pumped, the pressure released from here and the volume increased, as you can see by the balloon getting bigger. However, when I let pressure go back into this, the balloon becomes smaller because pressure is increasing, so volume decreases. Just how, as Boyle's Law states, as pressure increases, volume decreases, and as volume increases, pressure decreases.
That's our presentation on Boyle's Law. Thanks.